Hello everyone. Today we will see a problem on arrays. So the problem is we need to find the number of equilibrium indices present in the array. So we need to find number of equilibrium index. So what is equilibrium index? So an index is said to be an equilibrium index if sum of all elements before that index is equal to sum of all elements after the index. So which means uh, any index can be equilibrium array if and only if the sum of all elements before that index is equal to sum of all elements after that index. So let's take an example of this array. So we are having minus 3 2 4 minus 1. So this is index, zeroth index, first index, second index and third index. So we are having these elements minus 3 2 4 and minus 1. So now we will see how many equilibrium indices present in this array. So first we will take this first index, that is zeroth index. What is the sum of all elements before this index? There is no elements, so sum is 0. So what is the sum of all the elements after this index? This 2 plus 4 minus 1, which is 6 minus 1, which is 5. Is it equal? No. So this is not an equilibrium index. So we'll take the index 1. So what is the sum of all elements before this index? We are having only one element, so minus 3. And what is the sum of all elements after this? We are having 4 and minus 1. So the sum is 3. So is it equal? No. Minus 3 is not equal to 3. So it is not equilibrium index. So we will see whether if 2 is equilibrium index or not. So what is the sum of all elements before 2? Which means 2 means tooth index. So it is minus 3 and 2, which is minus 1. Now what are the elements after 2? We are having only one element, which is minus 1. So we will compare these two. Is it equal? Yes. So uh, we are incrementing this result variable, which is nothing but the number of equilibrium index to 1. So now we will check the 3 index 3. So what are the elements present before 3? 4 2 and minus 3, which is 6 minus 3 is 3. And what are the elements? There is no elements, so 0. So is it equal? No. So we are only having one uh, equilibrium index in this array. So the brute first we will see the brute force algorithm for this problem. So brute force algorithm is straightforward. So first we will traverse each and every index, and again we will check what are the elements present before this index, and we will add it all together, and we will compare that sum with all the sum of all elements present after that index. So how we can do that? So first we will traverse from 0 to n. So n is here nothing but the number of elements in the array. So we will consider array A or R here. So I'm just writing the pseudocode. So I'm not initializing anything in this array, and I'm not initializing this n also, because I'm just writing pseudocode. We already know n is the size of the array, input array ARR. So for I'm traversing each index. So for each index I need to find whether this element is, sorry, this index is equilibrium index or not. So what I have to do? So I have to find the sum of all elements before this index, which is nothing but I need to traverse from uh, I minus 1th index to 0th index, and I need to decrement the pointer here, this loop pointer, and I need to initially declare one variable as sum before. So sum before is nothing but array of j plus the sum before. So similarly, I am declaring another variable sum after, which is 0, and as we did before, uh, finding sum before, I am declaring sum after, which will traverse from I plus 1 to n index n, and I am going to increment this loop pointer because we are going from left to right, and this sum after is nothing but a r of j. So now once this sum is computed, we are just comparing the sum before, i- if it is equal to sum after. So if it is equal, then we are incrementing this result variable by 1. So here result variable is nothing but the number of equilibrium indices present in this array. So initially I am declaring one result variable as 0, and when I find any equilibrium index, I am incrementing this by 1, and finally I am returning this result, which denotes the number of equilibrium index present in this array. So now we will check the time complexity of this algorithm. So first we are traversing from 0 to n, which is n, and again we are traversing from 0 to that current index, and current index to n, which is nothing but another n times. So we are traversing n into n times, which is nothing but the go of n square. So this is the time complexity, which is nothing but quadratic time complexity, and space complexity is we are not using any space extra space here, so which is the constant big O of 1. So if you see, it is quadratic time. We are this algorithm is of time complexity quadratic, uh, and it is brute force algorithm. Hi, let us see now. Let us see the optimal solution for this problem. So in the brute force algorithm, if you see, for finding the sum before, we are traversing the array from 0 to I. So I is nothing but 0 to n. So we are traversing the array from 0 to 1, 2, 3, 4. So again and again we are traversing from 0. So what if we store the results of each index sum in a separate array? So while computing for any index from 0 to I, we can simply add ith index of original array and I minus 1th element of the sum array. So now the sum can be computed in big O of n time instead of big O of n square. So what I am trying to say is, instead of iterating from 0 to again n, like each time, instead of traversing from 0 to I, we will create a separate array and we will store the sum from 0 to I in the ith index of that sum array. So now for computing the sum of elements from 0 to ith index, we can simply add uh, ith index of the original array and I minus 1th index of the sum array. Similarly, for sum after, we can create one separate array, and from n to I we are traversing for computing this sum after. So it is n square times now, but we can simply introduce the sum array and we can uh, store the sum in each index from last. So for computing any sum at ith index, we can simply add the ith index of the original array and I plus 1th index of the sum array for finding the sum after. So this approach we will call it as prefix sum array and suffix sum array. Prefix sum array is nothing but storing the sum of elements starting from zeroth index is called prefix sum array. So suffix sum array is nothing but storing the sum of elements of the array from last index. So that is nothing but suffix sum array. So let us see how we can use this approach and optimal solution. So we are having this input array and we are having this result. So now we will introduce the prefix sum array and suffix sum array. So for finding prefix sum array, we can just uh, prefix sum array of any index is nothing but prefix sum of I minus 1 plus the original array plus ith index of original array. But if you see at 0th index, we don't have I minus 1th index in prefix sum. So instead, so at 0th element, we will just store the original array 0th element. So now we can compute this prefix sum in big O of n time instead of this nested loop big O of n square. So now similarly for finding suffix sum array, we will traverse from n minus 1 to 0 and suffix sum index I can be computed suffix sum of I plus 1 plus array of I. So similarly if you see at n minus 1 we will have this index, we will compute this index as n. So we don't have that nth index in any array. We will have up to n minus 1 only. So we will start from n minus 1 and suffix sum of n minus 1 is nothing but array of n minus 1. So we have computed the prefix sum array and suffix sum array. So now we will compare. So what we'll do is from 0 to n we will compare prefix sum of I minus array of I equal to suffix sum of I minus array of I, then result plus plus. So why I am negating array of I is, so prefix sum of I will contain all the elements from 0 to 1. So now we need to find the equilibrium index available. So equilibrium index is nothing but the sum of all elements before that index should be equal to after the index. So that's why I am negating the array of that particular index from prefix sum and suffix sum and comparing. So by this approach we can find the number of equilibrium index present in the array. So this result will have the number of equilibrium index present in the array. And if you see the time complexity is here we are having big O of n, big O of n plus big O of n, which is nothing but big O of n, and space complexity is nothing but we are using two arrays extra space, so which is nothing but big O of n. So this is the optimal solution for this problem. Thank you.